we're going to work on equivalent equations. Say that 3 times. Equivalent equations, equivalent equations, equivalent equations. Basically, all that means is one side is equal to the other side. So often we're used to doing a problem like this that says 5 plus 3 equals 8, and 8 is our sum, and we're done with the problem. In reality, this really means 1, 2, 3, 4, 5, and 3 is 8, and 1, 2, 3, 4, 5, 6, 7, 8 is also 8. They're equivalent. This side is the same amount as this side. It's just a different way of looking at it. But when you do equivalent equations, you really have to understand that, because you can tell 5 plus 3 does not equal 2. So one of the easiest ways to do this kind of problem is to go ahead and draw pictures or circles. So 1, 2, 3, 4, 5, and 3. 1, 2, 3 is 5, 6, 7, 8 on this side. Here we have 2, but we want to get to 8. So say the 2 and continue counting till you get to 8. 2, 3, 4, 5, 6, 7, 8. Now we have 1, 2, 3, 4, 5, 6, 7, 8, but we know we've already got 2 of them on this part. So this is what the missing number is. 1, 2, 3, 4, 5, 6. So now we know that 5 plus 3, which equals 8, and 2 plus 6, which equals 8, because 8 is equivalent or equal to 8. I'm going to give you a little clue if you remember the commutative property. We've got our 4's here. So if I've got 4 over here and I have 4 over here, and they're saying 5 here, this is a fast, easy one. You just have to put the 5 here. Because 4 plus 5 equals 5 plus 4. It's just switching the position of the add-ins. Okay, let's try the next one. Well, they want us to get this number first. And so let's go ahead and do the problem we know how to do. 6 plus 1, 6. One more is 7. We'll want to get to 7 on this side. We already have 2. Do you remember how we did the dots to figure out the missing add-ins? Let's try it. 2, 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5. We know that 5 and 2 is 7. 6 plus 1 equals 7. So 5 plus 2 is equal to 6 plus 1. This time they left this number missing. We know that 8 and 2 is a fast 10. Do you remember what you add with a 6 to get a fast 10? If you can't remember, let's put 6 in our head and use our fingers this time instead of drawing. 6, 7, 8, 9, 10. It's 4 more. So 6 and 4 is 10. 8 plus 2 is 10. So if this side is 10 and this side is 10, they are equal. Oh, we just did the problem. 6 plus 4 is 10. What do you add to 9 to get a 10? 9, 10. One more, and we will have both sides equal to a 10. 3, 4, 5. You should know 3 plus 2 is 5 without even using your fingers. Do you know what you add to 1 to get to 5 on this side? 1, 2, 3, 4, 5. 4 more are needed to get to your 5. Oh, this is what they want us to find the answer to. We can do this problem because 8 plus 1 is a 9. I want to get to 9 on this side. Oh, look, I'm at 9 already. I'm not going to leave that blank. Can you remember what you have to add to a 9 to keep it at a 9? It means you don't add any more, which means it's a 0. 0 plus 9 equals 8 plus 1. Here's our final one. It's a little bit harder. 11 and 1 more is a 12. I think I'll use my fingers for this one. I'm going to put the 4 in my head because I know I already have 4 on this side. And then count on to get to a 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. 8 more. So just remember, when you're doing a basic math addition problem, this is really saying this is 8, this is 8. When you're doing a more difficult problem, like an equivalent equation, make sure both sides are equal to the same amount. Bye.